So in this video, we'll discuss how to find the mean, variance, and standard deviation of the binomial random variable. We'll use what we learned about means and variances and standard deviations of sums of random variables. So on one trial, the mean number of successes is p, because with probability p, you get one success and 1 minus p0. Now, what's the variance on one binomial trial? With probability p, you get a 1, you get one success, subtract off the mean, and you square that. And probably 1 minus p, you get 0 successes, subtract off the mean and square that. And if you simplify that, you get the variance as p times 1 minus p on one trial. And then the variance on n trials, remember, you can get the variance of the sum of random variables by adding up the individual variances. You just multiply this by n. And then the standard deviation would be the square root. Perhaps an easier way to get the variance on one trial is to use our formula. The variance of a random variable is the expected value of the random variable squared minus the mean squared. Because what's the expected value of the number of successes on one trial? Well, with probability p, you get one success and 1 squared is 1. So this would be expected value of x squared is just p. And what's the mean squared? It's p squared. So you have p minus p squared, the same thing. Okay, so again, the variance on n trials will be n times the probability of success times 1 minus the probability of success. And the standard deviation is the square root of that. Again, we're looking at the number of successes. So we toss a coin 100 times. What's the mean and standard deviation of the number of heads? Well, n is 100. That's the number of trials. Probability of success is 0.5. So on the average, how many heads? 100 times 0.5 or 50. What's the variance? It's going to be 100 times 0.5 times 1 minus 0.5. That's 100 times 0.5 is 50 times 1 minus 0.5. Half of 50 is 25. And the standard deviation would be the square root of 25, or 5. Now in the next video, we'll start learning about a new random variable, the Poisson random variable, which has many exciting real-life applications.